Welcome to homework.
Hello everyone, today we're doing chapter 29, problem 68. And this problem tells us that in addition to using Fmoc chloride, you can also do Fmoc protecting using this mechanism or scheme here. And in A, it asks us to write out the curly arrow mechanism for the reaction that adds an Fmoc group to the amino acid. So here you just have your standard or generic amino acid. So we can make a let statement. Let this amino acid equal NH2R such that this NH2 is this NH2 and the rest of the entire group is the R group. So if I see that we're using sodium or carbonic acid, so we're going to have 2 sodium spectator ions and then the anionic carbonate group here in water. So first thing first, I recognize that I have a nucleophile of my amino acid, and I identify an electrophilic site being this carbon here, this carbonyl carbon here. So I know that using the lone pair electrons from the nitrogen, I'm going to attack this carbon, making a bond. You make a bond, you break a bond. So then this carbonyl oxygen bond is going to break and go collapse up. Now you're going to get this first intermediate structure. And then we have the R group, the NH2 plus R attached on to this carbonyl carbon. So now the carbonic acid can be used, or the carbonate can be used to now deprotonate the nitrogen to make everything neutral. And now we see if I just substitute these two groups for R and R prime, so this is R, this is R prime. So I can say I have R attached to this oxygen, attached to R prime. And now I have my neutral amino acid here. At which point now, using the lone pair electrons on this nitrogen nucleus, we identify that we have lone pair on nitrogen, but we also identify that this oxygen has an extra lone pair electrons because of that formal negative charge. So it's going to be more favorable for this oxygen to reform that pi bond to regain neutrality and in the process kick off the leaving group. So the best leaving group is this group here that is going to fall off. And we know that this is going to leave not only because of the high electron withdrawing effect of this leaving group, but also because it tells us in this reaction scheme. So we made a new bond, so we got to break a bond. So this the sigma bond, between this carbon oxygen is going to break, but it's not going to form an O- in solution because it's in acidic conditions. So it's right away going to pick up that proton on this carbonic acid that was just added in the previous step. So now what we're going to have is actually we're going to form the final product. That's going to be now the Fmoc-protected amino acid. Plus N-hydroxysuccinamide. So now in B, it asks us to do the exact opposite. So it asks us to draw out the mechanism for when we want to do an Fmoc deprotection using these reagents. So when we want to remove the Fmoc group to regain our native amino acid, we typically use this base and some sort of organic solvent. So we can say that this base, the reason we use this base is, well, we know that there's going to be some spontaneous decarboxylation. So we can say that this base is going to pick up this proton to make a negative charge here. So now, then I'll let the rest of this equal R. So now we have this carbanion formed right here. And this is actually very important because this actually allows us to do spontaneous decarboxylation. So here we see that carbon does not like to have a negative charge, so it's going to use this lone pair electron to form a new pi bond, making a bond. You make a bond, you break a bond. So these two electrons on this carbon-oxygen bond are going to break to form CO2, which is going to spontaneously fall off. And the reason it's going to fall off because, well, now we made a new pi bond here, so we made a bond. We're going to break a bond because nitrogen, or sorry, this carbon cannot have 5 bonds. So in order to prevent having 5 bonds and make sure it just has 4 bonds, it's going to break off this bond here to go through the nitrogen nucleus. And that nitrogen nucleus is going to pick up its proton to stay neutral from the base that we added in the first step, which is protonated now. So it's going to pick up this proton from this base to regain or reform our native base and to form our free amino acid. So in overall, we see that it's a very concerted mechanism. Overall, we form this plus CO2 plus our free amino acid in B.